go right into an example. So here I have tangent of 300 degrees. Let me draw a picture of this. So 300 degrees means I'm in quadrant 4. This would be 300 degrees. My reference angle here would be 60 degrees. You can just do 360 degrees minus 300 degrees. And so what this big idea is telling me is that to find tangent of 300 degrees, I know this is going to be plus or minus tangent of 60 degrees. But I need to figure out whether it's positive or negative. It can't be both. And so this is where we're going to be looking at ASTC. Remember, ASTC tells you where sine, cosine, and tangent are positive. So here we're looking at quadrant 4. And in quadrant 4, only cosine is positive. What does that mean then? Then that means that tangent of any angle in quadrant 4 must be negative. So going back here then, if I want to find tangent of 300, I know I'm going to be looking at negative tangent of 60 degrees. Right, so again, I determined it was negative because 300 degrees is in quadrant 4, and I know tangent of any angle in quadrant 4 is negative. And then I'm finding tangent of 60 degrees because 60 degrees is the reference angle of 300 degrees. From here, this is just an acute angle, right? It's negative tangent of 60 degrees, which we talked about earlier. So it'd be just negative square root of 3. So again, make sure you know the trig functions of those acute angles because you're going to see them again and again and again. Let's look at another example together. Here we have sine of negative 13 pi over 4. So before I even do anything, what I'm going to do is I'm going to make this angle a little bit more manageable. And this is where we're going to be using coterminal angles. So what I'm going to do here is because it's such a small angle, I'm going to add 2 pi to it. By the way, this is the same thing as just adding 8 pi over 4. This is just negative 5 pi over 4. If you don't like dealing with negative angles, you can add another 2 pi if you want, right? And I'll get 3 pi over 4. So visually, this is an angle in quadrant 2. Right, we know that if I go 180 degrees, that's just pi radians. So this is a little bit short of that. This is just 3 pi over 4. But the question is, what's my reference angle? In this case, my reference angle would just be pi over 4. One way you can do that is you can take pi and subtract it by 3 pi over 4. And when you do, you're just left with the reference angle that you're looking for. So at this point, I want to find sine of negative 13 pi over 4. This, by the way, when we did coterminal angles, is the same thing as sine of 3 pi over 4. Because remember, coterminal angles have the same trig values. Now, from here, I'm looking at an angle in quadrant 2. Here I'm going to put ASTC. I know that sine is positive in quadrant 2. So when I'm deciding whether my answer is positive or negative, I know it's going to be positive. And for the reference angle, since it's pi over 4, I know that it'll just be positive sine of pi over 4, which is just root 2 over 2. So there's really two things you're doing here. One, you're determining is my answer going to be positive or negative. That all depends on what quadrant your angle lies in. And then the second thing you're going to do is find the reference angle. Because ultimately, you're just going to be finding sine of that reference angle in this case. And your reference angle will always be acute, right? So this goes back to when we talked about the trig functions of acute angles. So at this point, I want you to pause the video. And when you're ready, try number 3. So here we have secant of 240 degrees. Let's just draw this angle out. 240 degrees is an angle in quadrant 3. I'm going to write ASTC. I'm going to do this in a different order. Now, secant, by the way, we know is the reciprocal of cosine. So really the question is, in quadrant 3, is cosine positive or negative? Well, in quadrant 3, I know tangent is positive, right? And because tangent is positive, that tells me then that cosine must be negative, right? Which means secant of 240 degrees must be negative. I'm going to put a negative here. Now from there, I'm going to find the reference angle. My reference angle is this angle here, right? The acute angle that the x-axis and the terminal side make. In this case, I can do a simple calculation. I can take 240 degrees and subtract it by 180. That gives me 60 degrees. So really, I'm going to be taking negative of secant of 60 degrees. At this point, you want to find secant of 60 degrees, and that should be just 2. So in the end, my final answer is just negative 2. Okay? Try number 4 on your own, and when you're ready, press play. Here, negative 8 pi over 3 is a pretty small angle. I'm going to make it more manageable by finding its coterminal angle, adding 2 pi. If I do that, I get negative 2 pi over 3. For this one, I'm going to leave it as negative 2 pi over 3. I'm going to draw this angle in standard position. Because it's negative, I'm going to go clockwise. I'm not going to go a full pi radians, so I'm going to be short a little bit. And this is negative 2 pi over 3. So really, when I'm finding sine of negative 8 pi over 3, using coterminal angles, I know this is the same thing as sine of negative 2 pi over 3. Now I'm going to ask myself, am I going to get a positive or a negative value here? So all students take calculus in quadrant 3. I know tangent's the only trig function that's positive, which means sine must be negative. I'm going to put a negative here. At this point, I'm going to put sine of an angle, and that angle is going to be my reference angle, which is this angle right here. How do I find that? I can just take pi and subtract it by 2 pi over 3. And if you simplify that, you get pi over 3, and that's going to be my reference angle. So what is sine of pi over 3? Again, this is an acute angle. If you remember from what we did earlier, this is just square root of 3 over 2. So for this one, we're going to find the exact value of the remaining trig functions of theta. This looks kind of familiar, right? Here they give you one of the trig functions. Sine of theta is negative 2/3, and they tell me that cosine of theta is negative. First thing you want to do is figure out what quadrant you're in. So let me draw my xy plane. Once again, I want to figure out what quadrant I'm in. I know that if sine of theta is negative 2/3, think of ASTC. For sine to be negative, I must be in quadrant 3 or quadrant 4 because I know sine is positive in quadrants 1 and 2. Cosine of theta is negative in quadrants 2 or 3. The reason why I know that is because it's positive in quadrants 1 and 4. Keep in mind, a trig function is usually going to be positive in 2 of the quadrants and negative in the other 2 quadrants. Now, if you look at both of them, they have quadrant 3 in common. So that must mean my angle is in quadrant 3. What I'm going to do next is I'm going to draw an angle in quadrant 3. In particular, I'm going to draw a right triangle. So here I'm going to call this theta. Let me draw a right triangle here. And because they say sine of theta equals negative 2/3, I know that if I take sine of its reference angle, that'll just be positive 2/3 because again, alpha is my acute angle, right? This is alpha, by the way, my reference angle, always acute. So if I label my sides, sine of alpha is 2/3, sine is the opposite of hypotenuse. Opposite would be 2, the hypotenuse would be 3. Using Pythagorean theorem, you'll get this leg here to be square root of 5. And now from here, what we can do is we can find cosine of theta. And because we're in quadrant 3, I know that cosine is negative there. So I'm going to be getting negative cosine of the reference angle. So looking at alpha, cosine is just adjacent of hypotenuse, and this is just square root of 5 over 3. Going to do the same thing with tangent of theta. First off, I know that we're in quadrant 3, and tangent is positive. I'm going to put a plus sign here just to make it clear it's positive. And I'm going to be finding tangent of that reference angle once again. Opposite of adjacent would give me 2 over square root of 5. And if you rationalize that, you get 2 square root of 5 over 5. And then from there, we have to find cosecant of theta, which all I'm going to do is take sine of theta and take the reciprocal. So I get negative 3 over 2. Then I'm going to find secant of theta. Once again, I'm just going to take cosine of theta and take that reciprocal. that will give me negative 3 over square root of 5. And if I rationalize that, I get negative 3 rad 5 over 5. And then to find cotangent of theta, I'm just going to take the reciprocal of tangent of theta. That's going to give me rad 5 over 2. And so what's going on now is we're combining pretty much everything we've learned up to now, and we're throwing it in all together to find all 6 trig functions of theta. So I'm going to show you another way you can do this problem, which even though the notation isn't completely correct, it'll give you the same answer, and it might help you minimize making those positive or negative mistakes. So I'm going to draw an angle in quadrant 3, standard position, with my angle theta. Let's draw a right triangle here. And I'm going to call this angle here my reference angle as usual. Now we know that sine of theta is negative 2/3. The hypotenuse is 3. Earlier we labeled a triangle like this, right? Now if you look at this point right here, right? This point would be negative square root of 5, negative 2, right? It's a point in quadrant 3. What I'm going to do is I'm going to put a negative here and a negative here. And when I find sine, cosine, tangent, I'm just going to be using this triangle here. And by using this triangle, that's going to take care of all the negatives. So for example, if I want to find cosine of theta, which I did earlier, cosine of theta, I can just use a reference angle here, use adjacent over hypotenuse. I'll get negative radical 5 over 3. So I get a negative value, just like we did earlier. If I want to find tangent of theta, I'm going to look at my reference angle here and use opposite over adjacent. Negative divided by negative gives me a positive, and I got a positive answer earlier. For cosecant of theta, right, that's just a reciprocal of sine. That would be the hypotenuse over the opposite, but once again, you get a negative value. So by labeling your triangle using positives and negatives, you'll be able to find the trig functions using SOHCAHTOA and the reciprocals, and you don't really have to worry about the negative. Now, the reason why this is bad notation, though, is because side lengths of a triangle are always positive. But if you see how I label this, you can use this to also find the 6 trig functions of theta. So for this problem, I want you to change this actually. Let's make this tangent of theta to be less than 0. At this point, I want you to pause the video, try this problem on your own, and when you're ready, press play. So let me draw my 4 quadrants. ASTC, all students take calculus. Cosine of theta is negative, which means I'm in quadrants 3 or quadrants 2. Tangent of theta is negative, which means I'm in quadrants 2 or 4. So if you look at the overlap, we know we're in quadrant 2. So let me draw an angle in standard position that lies in quadrant 2. And then I'm going to draw my right triangle here. This is my reference angle. This is theta. Now they tell me that cosine of theta equals negative 1 over 4. So that means that cosine is adjacent for hypotenuse. So that means I know that cosine of the reference angle is 1 over 4. So I can label my adjacent 1, my hypotenuse 4. And if you use Pythagorean theorem, you'll get square root of 15. And then from there, I'm going to find the other 5 trig functions. To find sine of theta, I know that because we're in quadrant 2, sine is positive. So I can just use sine of the reference angle, looking at my triangle here, right, and using this angle. Sine of that angle would just be opposite or hypotenuse, which is square root of 15 over 4. I already know what cosine of theta is, but I'm just going to write that anyways. This is just negative 1 over 4. Now I'm going to find tangent of theta. In quadrant 2, we know tangent's negative. So it's going to be negative tangent of the reference angle. In this case, tangent of alpha would be opposite or adjacent, or just square root of 15. To find cosecant of theta, I'm just going to take the reciprocal of sine, which is 4 over radical 15. And if I rationalize this carefully, I should get 4 rad 15 over 15. I'm going to find secant of theta by taking the reciprocal of cosine, which is negative 4. I'm going to find cotangent of theta by taking the reciprocal of tangent, which is negative 1 over square root of 15. And again, if you rationalize it, you get negative square root of 15 over 15. So the two concepts that you want to make sure you understand really well are how do you find reference angles, which trig functions are positive or negative in all the quadrants, and then combining all the concepts we learned about for trig functions of acute angles. So this section is pretty meaty. Make sure you go back and really practice and do your homework problems. If you have any questions, please ask.